the button. Physics video. I don't know if I really have anything specific to add. I'm just going to react to this video that Hoffaday posted, BBC, and this Professor Jim whatever. It's not that cuckoo guy. It's some other, this cuckoo guy. Anyway, it's more this quantum crap, and there's just the whole propaganda way they present it to the lay person, and it's just so wrong. They talk in such absolutes, and about stuff they can't draw a picture of. They can't draw a picture of it. They don't. They flip coins or do some other silly shit and say, yeah, it's just like that. No, it's not just like that. And the whole characterization of the evolution of this physics for the last 100 years is more of the same kind of pigeonholing and trying to force it to go one way or another way, or this way or that way. It's just so wrong. It's not scientific. It's not careful. It's not well-founded. It's not a good trial. Okay, the trial of reality through quantum physics has been a mockery conducted by physicists. They've made a mess of it with their Copenhagen and their all this other crap. It's crap, and they need to go through each stage and each step and look for how they could be wrong, instead of assuming that, well, that worked out okay. Let's just say it all. This is why it worked. And this is why, so these simple, well, it's not even simple is the problem. I think it is rudimentarily simple. So anyway, but my fundamental gripe is, so every time they describe one of these experiments, the two-slit experiment or some other experiment, which they don't even do with electrons anyway, it's not a two-slit experiment, they shoot it through a crystal, which is, it creates even more problems in terms of figuring out what exactly is happening to photons as they're interacting with the matter. And again, so that's my gripe. So there's no concession that this isn't cannonballs and whatever holes in castles or some windows. This isn't cannonballs and windows. That's not the material world that photons exist in. They don't pass through windows. They pass through a lattice, a structure of the universe that's full of something else. It's not bricks. It's not made out of stuff and then non-stuff. It's not the way it functions in their world. Their world, there isn't this delineation between matter and non-matter, in the sense that every edge is not a straight line, and there's a lot of complex movement going on. Everything's waving in front of them. Nothing's sitting right here, just staying right here. There's no such thing as a brick that just stays in one place in the universe. The universe doesn't have any bricks in it. They aren't moving. They aren't actively made of matter, which is actively moving. And there's just no... They start off... Well, here's bricks right here. They start off talking as if this is a brick and mortar world that photons are interacting, like they're working, like it's in a bowling alley or something. It's not a bowling alley. So even if you can argue, as I think is appropriate to argue, that photons are themselves quanta, discrete bits. They only do one thing. They move the speed of light from here to wherever they're going. That's it. They don't do anything else. They have no other property. Of course, they have polarization. Okay, so I already said something I was a little too quick to say. They have properties, but they are really simple properties, not complex properties. Yeah. Alright, and so there's no, so that's my biggest problem with this, is that there's no concession that this quantum world is so much smaller than our world. so tiny, these things, and that we don't have a picture of it. But we can deduce things through these experiments that are done. You pass light through glass and you see it slows down. Well, you know the light didn't slow down, so now you have to account for somehow it traveled more distance. Somehow it didn't travel a straight line through the glass, because you have to account for the fact that it took longer to get to the finish line. And it sort of makes sense if you sort of understand that there's a relationship between photons and electrons. That electrons communicate with each other essentially. They transfer energy to each other with photons. This is something this is a reasonable, from the volume of evidence collected, that can be gleaned, is that electrons, seems to be their primary function is to absorb and emit photons. That this is what they do all day. They don't do much else. This is what they do. Yeah, they collect the energy of a photon, and they release the energy that they have collected. Okay. I guess and then it's all this other dynamics you have to get to about what light is. Light it's produced by electrons. Electrons produce the light. Any light you see, and it came probably from an electron, because it had, even though I would say that the light itself, the photon itself, has been floating through the universe forever, or for as long as the universe has been the universe, the photon has been moving the speed of light all that time. It's never stopped going somewhere. And all that's happened is it's gotten caught in patterns. But it's never stopped. It's always been on a mission. It's going home somehow. But that's what it's been doing. And when something emits it, it doesn't, if I see light, that light isn't coming to me as a perpetual, like the light from a star. It isn't like a stream of light. There isn't just like from one electron, and the one electron just keeps producing photons that come to my eye. No, there's a region that's producing a consistent amount of photons, but there's a whole bunch of, they're a little bit off, a little different, slightly different, because they were emitted by different electrons in different positions with different character. And so you get chunks of photon, 2 here, 2 there, 3 there, 4 there, whatever the amount might be, in a row, and that would, and their distance from each other decides their frequency. So there was a couple of illustrations in this video that were just terrible. So one of them was dealing with the ultraviolet dilemma or catastrophe, or however they describe it. This problem with why is matter vulnerable, reactive to certain energy in the form of light, and not reactive to other energy in the form of light. So there's this circumstance where you can't make an electron change its size or do something electrons do by just throwing infrared photons. You have to throw an ultraviolet photon. And so they demonstrate this by throwing sponge balls at a target, and then throwing golf balls, something more solid, implying that the quanta of the blue light is somehow more dense. And I think it can be rationally argued that that's not the issue here. The issue is the amount in terms of the frequency, how often you're hitting something. Again, so I made my argument that things have tipping points, and if you poke something slowly enough, you can poke it all day long and it'll just keep bouncing back, and so you'll never knock it over. But if you poke it quickly, then it doesn't have time to bounce back, and so with each poke you'll push it to its tipping point. So the machine gun is more effective than the single bullets. Doing certain, like moving a car. If you want to move a car with a gun, yeah, you're more likely to do it by hitting it with a machine gun. more likely to do it by increasing the frequency of the impacts to prevent any bounce back, any equal but opposite reaction from happening. If you hit it before it can equally and opposite react, you can do more damage. You can change it more fundamentally. So how photons interact with something, how frequently they do, is just as significant as how much photons you're reacting with. But that truth isn't anywhere in this in this presentation of how photons convey their energy. So anyway, I'll just play some bits of this, and I guess I'll just wander through it, and because it's all just crap. So here we're doing some little history.
Realize was that they would also unleash a scientific revolution. Strangely enough, this humble object is responsible for the birth of the most important theory in the whole of science.
There we go. So it's full of that kind of rhetoric, like quantum mechanics. This is the most important thing that ever could have possibly happened. This is it. It's just full of this propaganda. You know, there aren't a whole bunch of scientific discoveries that were, hugely important besides the invention of some probabilistic theory regarding quantum mechanics. Again, I don't think quantum mechanics was at all necessary to any of the progress we've had. If they never invented the term quantum mechanics, they still would have realized that silicon, can be manipulated into a semiconductor. They still would have invented transistors, solid-state transistors. All these things would have still happened without the idea of quantum mechanics, or the idea of wave versus particle. None of that was necessary to any of this invention, and they just keep talking as if it was. And it's really irritating that they're trying to make this theoretical physics relevant to real physics, and it's not.
Quantum mechanics, a theory that I've spent my life studying.
Right, propagandizing now, apparently. So yeah, you studied it, and now you're just a propagandist for it. Because that's all this whole frickin' thing was just propaganda. Useless propaganda. Nonsense, drivel. So, yeah, let's play some.
This kind of measurement, just much more accurately. The temperature inside here is 841 degrees centigrade.
Okay, so this is the black box part. So he's just pointing out how, see, it's orange light, and then when we make it hotter, it's white light. And so they're saying, why doesn't it go blue? When we make it really, really hot, why isn't the sun producing blue light? It's really hot, it should be producing blue light. Why doesn't it do it? And their explanation is kind of wanting, in my opinion. This is the part where they go with Einstein, because Einstein basically said this is what demonstrates basically that the quanta is a reality, that there's a discrete and realness to photons. They're not waves. They're not ambiguous. They have a discrete and real potential, something like that. It's all or nothing. Yeah, that's Einstein's. And that basically I'm making the same argument. I'm saying, look, everything in the universe is made out of photons. There is nothing else. The photons are just in patterns. They're trapped in spirals. That's it. That's the universe. And why certain frequencies of photons, when they come at something, they'll affect it differently depending on how quickly they interact. And likewise, the atoms themselves can only create photons of a certain pattern. They can't just shoot them out any speed they want to. How fast the photons are released from an atom, an electron, is going to be completely dependent on how big a circle the electron's making. And I would argue that we can make some assumptions about the idea that they do come in pairs. You know, that when a photon flies out of an electron, that it's likely flying out in some kind of way where, yes, they're going around in a circle like this, but they're tied to each other. And when you flip one out, the whole thing spins in a direction, and the other one gets flipped out, or however that works. See, that's the whole thing, is we don't have a mechanical, we don't have a description of the mechanics, the ropes of photons, the way they are tied to each other through these loops and strings and mechanical strings. Again, I don't want to imply that there's anything else. A photon is probably just you could think of it as an S hook, right? It goes this way and it hooks this way. So they can be hooked onto each other. And that hooking is what makes it possible to tie everything together eventually. And it's just ropes made out of hooks and loops made out of hooks, and all the pieces are moving at the speed of light.
Yeah, I hear you, but I gave you food.
No. No. Jeez, you got extra food. You got, you know, you're just not getting anything else. See, now he just sits there at the dish. Come on. You want to go out? Go out and quit harassing me with your guilt mongering. I was a guilt mongerer. Anyway. Sorry, yeah, this is really a great video. So, like I said, I just want to get to the point that there's a whole pile of, there needs to be a more explicit model. If you're going to say something like, oh yes, photons are communicating with each other across zillions of miles of space, instantaneously. I mean, come on.
I can feel the heat coming off.
Next.
And it's glowing with a lovely orangey red.
Yes, lovely, lovely, lovely. It's just such a pile of
Look
crap.
at the shadow of my hand. It's fuzzy around the edges. We understand this as the light hitting the sides of my hand and bending and smearing out slightly, just like water waves around an obstruction.
Yeah, just like water waves around an obstruction. Is that how water waves work? Is it just like water waves? I don't know. And can't it just be explained it also is particles who are statically, you know, like again, if the matter of my hand is not just matter, it's covered with a whole field of electrons based on its charge. So this can't be explained as just the same kind of blurriness that you would expect when something is going through a mushy area, not solid, not empty. That would be around all matter, you could presume, because matter doesn't have some sharp edge. It's made of electrons spinning and atoms spinning. Yeah, I think so. Anyway, moving on.
And even heretical.
So all this, I don't even know what they were doing here. I mean, they kept raising and lowering this giant telescope, you know, phallic symbol thing. They just kept raising and lowering it and raising it and lower through the, you know, through 20 minutes of the video. They just kept up and down the boner. I just really, I mean, it was just almost childish. Let's put some porn in the physics video. Okay.
Ultraviolet light are enough to knock the electrons out of the metal plate and collapse the gold leaf.
There, so knock it out of the metal plate and collapse the gold leaf. Well, anyway, so this is just an explanation that the ultraviolet light has an effect on the character of the matter, in the sense that it changes the charge that the matter's, you know, the metal plate would be here and it would be connected to the little gold leaf, and the gold leaf has a charge on it, forcing the two pieces apart from each other. So now the character of the two pieces has been changed in some way to create a magnetic force. And yes, you can shine all the infrared light you want to in the world on top of the plate and nothing changes. But if you shine ultraviolet light, something changes. And yeah, the argument would be is that infrared and ultraviolet light are going to affect atoms differently. And you know, they're going to impact on an electron differently, because the pieces of them are going to hit the electron more frequently in a given amount of time. And we're back to sort of my tipping argument. But yes, if something's vibrating and you hit it with the vibration, it's very different than you hit it when it's moving this way. So if something's bouncing back and forth, again, there's another argument that if you want to add force to its movement, hitting it when it's in one direction will add force to its vibration. Hitting it when it's moving in the opposite direction will take energy out of its vibration. That's not too bold a statement to make, is it? No.
But, and I might get into trouble for saying this, I would argue that the upheaval that took place in physics at this time would eclipse them all. And
right, so again, it's just physics is just so important. In the 1920s, they were doing all this roaring crap, but the real roaring was physics. Whatever. Yes, people were paying attention. They did make a star out of Einstein and all that kind of crap, but let's not, this is preposterous exaggeration. It really is. I mean, it's pretty freaking silly. So anyway, we'll move along. I mean, all of this bullshit. This is science. This is how we teach science.
I have a water ripple tank placed on top of an overhead projector.
Right, now this is just a great example here too, right? These are water waves, okay, and look at the gigantic slits. I mean, no explanation of how waves, which are completely a function of tension in a medium, okay, completely a function of the tension in the medium, that is the adhesion between water molecules, how this has absolutely nothing to do with what's happening in this two-slit experiment with photons. So, photons, obviously, it's not these wide slits like this and all this stuff. But, and see, they're coming in with the wave. So, but this experiment could be just as equally done by just vibrating this material. All this stuff is vibrating from a photon's perspective. None of this stuff is static. So when a photon's coming at this material, it's not, this material isn't just sitting here like this and the photon just drives right through. No, this material not only has a charge of electrons flying around it, an aura of them, so to speak. Okay, it's electrostatic. Okay, but besides that, this stuff is moving, and it's moving a lot. It has lots of different frequencies it's vibrating at, very slow ones and very fast ones. So it's got a lot of frequencies built into it. It's vibrating quite dramatically, probably from a photon's perspective, when you consider that this slit is very small from a photon's perspective. Now, wouldn't you expect that if I was pushing water, just water with no wave in it, through something that was moving, that the water droplets would maybe come out in different directions based on how they were influenced by the movement of this matter? And that you'd end up with a pattern because of that movement. Because with each instance you have a different mathematical probability of what part of the cycle this matter would be at. What part of its cycle is it moving at? And especially if I concentrate the light right on these edges. So most of the light hits here or hits here. If I do that deliberately, you can imagine that if I deliberately, I have something moving and I deliberately force most of the light to go right at that edge of that moving, then I'm going to end up with a pattern that's going to reflect that vibration. Right? I mean, this is just an inadequate way to describe it. And what they're describing is a filtered pattern. They keep saying that this is the only thing you can ever explain this with is an interference pattern. And no, you can explain it with Newton's glass, right? So again, we're back to the layers of glass. Newton did these experiments with layers of glass, and he did this experiment of polishing the glass down and found that as you make the glass thinner or thicker, it changed how much light reflect off the surface of the glass. And it creates this quandary of, you have to say to yourself, well, how does the photon know how thick the glass is? How does it know how to reflect on the surface based on how thick the glass is. So you'd have to recognize that, well, maybe there is information in the structure of the matter itself. Maybe the glass knows how thick it is. Maybe the atoms align differently based on how thick the glass is. And so as you, and the thing was is it would be a repeating pattern. The pattern would repeat. Okay, you would go 4, 8, 16, 8, 4, 0. 4, it's a pattern. The same pattern you get here. Exactly the same pattern. And so it's not an all or nothing that happens here. These crests and preaks have they do exactly that. They do a 16, an 8, and a 4 kind of ideas built into them, to some extent. And so it's the same idea. The same phenomenon is being realized. And maybe the realization should be that this is a phenomenon of matter, not a phenomenon of photons. That this is a phenomenon created by the structure you're obliging photons to interact with, not something built into photons. Really.
Then, with two other scientists, Nathan Rosen and Boris Podolsky, Einstein thought they'd found a way to win the argument.
So this is something Einstein's saying basically, well, this quantum mechanics crap that you know, to the extreme you've taken it to, this wavy crap, yeah, you're just waving reality out of existence. And so, yeah, they come up with thought experiments to say it ain't going to work. And so Einstein's thought experiment is the spooky action at a distance, that the implications of what you're saying is that, you know, a pair of objects separated by a great distance created in the same circumstance would somehow have to communicate with each other. I don't know why exactly that would be, but it doesn't matter.
He was convinced he'd found a fatal flaw in the Copenhagen interpretation.
Yeah, well, the Copenhagen interpretation is that the photon goes through both slits, interferes with itself, and then decides by probabilistic circumstances where it's going to resolve itself. So it figures out what the previous photons have all done, and it decides to probabilistically fit into that grouping. It figures it out somehow, which is a stupid interpretation. I think the more sensible interpretation is that as the time clicks, the vibrations of the matter is happening, the vibrations of a photon, the vibration that the photon's going to interact with in 1 second is going to be different than the vibration in the following second. The matter will have moved. The targets everything keeps moving. It's not a static target, it's a moving target, so to speak. And that's why you're hitting a different place on the target. It's because it's moving. I don't mean literally the target that the photon is hitting. I mean the structure that's creating the direction of the photon is moving.
And it's claimed that reality was summoned into existence by the act of looking at it. At the heart of Einstein's argument was an aspect of quantum mechanics called entanglement. Now, entanglement is this special, incredibly close relationship between a pair of quantum particles whose fates are intertwined.
Right. For example, we haven't proven any of that, and this is all just, in my opinion, made up crap. But fine. Now let's move on.
And breakthroughs in nuclear power.
I mean, to be clear, I'm for the idea that photons are likely created in pairs, that you can't have a resolvable or a recognizable photon unless it is with a pair. It's the only way you can see its frequency. The only way you can have an identity versus radio wave versus cosmic ray. The only way you can tell what it is it has to have another one with it. There has to be two of them for them to have a period. And the period is what defines it as a photon. If it has no period, if it has no constituent other with it, then I think it's a graviton.
Quantum mechanics was so successful that most working physicists deliberately chose to ignore Einstein's objections.
Well, you know, this is what a way to put it. No, they ignored all objections. They ignored all everything. They didn't care because they didn't need any of this theoretical physics to do physics. They already had substances, and just like Newton, they could shave, they could polish glass, they could do things. Newton didn't need quantum mechanics, and look at all the crap Newton did. Look at all the experiments Newton did. And he didn't need quantum mechanics to do any of them. And we're still basically pondering the experiments he did. So this is just, you know, just such propaganda. What all physicists were thinking. All physicists were thinking is, I'm going to make a better mousetrap. And, you know, we have some tools to do that with now. We're learning how to do things. We're learning how to manipulate matter and make it do things. But they didn't draw it on a piece of paper first. That's what you're saying, and they didn't.
It simply didn't matter to them because it worked. They even coined a phrase for it: shut up and calculate.
Yeah, exactly. So you do some basic math. Well, there's some basic math in quantum mechanics. Yes, you recognize that, like even Newton had already established the math, in the sense that he already established the math for quantum mechanics, in the sense that he had established the ratio. And the fact that, yes, if the glass is this thin, 8% will reflect. If it's this thin, 16% will reflect. If it's this thick, 4% will reflect. So he'd already done the math, so to speak, to create he already created the numbers for you to put into the math. Again, long before the invention of quantum mechanics, the math already existed.
He famously said, "I hesitate to think it might be wrong, but I know it is wrong." And so, in the early 1960s, Bell decided to...
Alright, I hate to think that it's wrong, but I know that it is rotten. And this has to do with Bell and his mathematical equation that somehow demonstrates something, and I'm not exactly sure what it demonstrates, in the sense that it's just the experiment that goes with it to create this idea of the spooky action at a distance, this entanglement thing, is an experiment that does, again, it has so many moving parts, and literally moving parts. You're saying, how could this be of any value at all, right? So you're going to split a laser beam, split it into two, and then take the two pieces of the laser beam and make them do things, okay, in different places, and then say that you have the brother laser beam is over here and the sister here, or, well, identical twins we'll call them. So Jim, one photon, Jim is over here and John is over here, the two twin photons, and you're going to be so precise in what you're doing that when you are looking at Jim over here, you're looking at John over there. So that means that every mirror has to be exactly the same thickness. Everything you reflect off has to be exactly everything has to be so frickin' exact, because the frequencies of these things are millions of cycles, thousands of cycles, no, millions. Well, whatever. It's a lot. So it has to be very, very. So yeah. So you know, there's huge margins for error, and all this math ends up calculating on like they have 98% of their results from this experiment are error, and there's 2% of good stuff, and so they're assuming that their 2% is pretty good, just because because it's piled on top of this huge error. So but you can still see the 2% floating somehow on the surface of the pile of mush. So it's like it's a sea of poo with one hot dog in it. And you're going to somehow tell the difference, because the one hot dog will somehow always make itself known. The 2% of credible result will somehow exist as a probabilistic outcome. And I'm not saying you can't do this theoretically, that some of this has value in the sense that it will have some kernel of representation. But everything has to be so fine here, and your margin of error is so thin, that how could you possibly draw any conclusions? You can't. But they do. So anyway, the rest of the video is the Bell inequity and spooky action bullshit.
Thing is, at the time, the entire physics community ignored him. Total radio silence. It seems the world simply wasn't ready.
It wasn't ready. Wasn't ready for what? Another piece of obscure mathematics that really doesn't have, that there's no way to prove or disprove. So yes, they weren't ready for doing whatever. Something they can't, they had no experiment to use the formula for with anyway. And so now they've contrived the existence of the experiment. They've made one, so to speak, and assumed that it works. Then that's all. They've just assumed. They know that not only do the photons they're creating, they're created as pairs and they're opposite each other, but they know that even though they put them both through different cycles of interaction, that they're measuring real results. I don't think they know any of that.
The two photons are like the two cards the evil dealer places in front of me. We'll measure a property of the photons called polarization, which is equivalent to the color of the playing cards in my game. So...
Yeah, well, says you. But anyway, and then he changes it to, now we're measuring something else and we're measuring something else, because he obviously can't make an analogy for this complex experiment out of playing cards, because the complex experiment has so many more moving parts than the card game. So yeah, the whole thing kind of breaks down as, well, this isn't really what you're doing, and this isn't really what you're proving. So anyway, it was all pretty pitiful.
The two entangled photons' properties couldn't have been set from the beginning, but are summoned into existence only when we measure them.
So there's the big bold conclusion, right? He says, we have proof now. This is absolute proof. So there's no variables in photons. There's no variables created by how you manipulate them through, shoot them through a crystal, split them, hit them off mirrors, bounce them around. There's no variables in any of that process. None of that changes the nature or function of the photon. It's all pristine and pure. And none of that can ever explain whether a photon is on or off, or whatever you want to measure it's a piece of its character. It's the minor properties that photons have, polarization being one that you can measure. And I'm supposed to say that's proof? Scientist says that's proof? No, I say scientist needs to do a little better than that. I'd say that might be proof for the religious. You know, God exists because I was going to get an airplane and a little voice told me not to get on it. So there, God must exist because he must have told me not to get on the plane, right? That's proof. Proof God exists. That's about how good this science is.
Something strange is linking them across space. Something we can't explain or even imagine other than by using mathematics.
Yeah, so, again, see, yeah, says you. Okay, you're saying this. I don't think you've proven it. I don't think you've proved that any such thing as entanglement in any way. Yes, they had properties going in, just as Einstein said. It's a left-handed glove and a right-handed glove, and yeah, if you open one box and there's a right-handed glove, well, the left-handed glove must be in the other box. That's right. No surprises. They don't decide in some later time. Photons have the character of their interaction. What they interact with will decide where they're going to go and what their character is. Period. Photons decide absolutely nothing. The environment decides where they're going to go and where they're going to be. Nothing decides anything. It's always the environment it's interacting with. The environment is the container. Without the container, it just flies forever in one direction. It just does one thing. Without the container. Well, anyway. So they just got they got the fundamental part wrong. So let's see if we can get to some of the real heavy propaganda at the end.
Weird results of quantum mechanics. But one thing is clear. Whether there are physical spooky connections, whether there are parallel universes, whether we bring reality into existence by looking, whatever the truth is, the weirdness of the quantum world won't go away.
Alright, says you. I say it will go away when you get a rational model. And it'll go away really easy. And you'll be amazed how easily all this voodoo goes away. All this, as you just said, the world, we create the world through perception. Oh, please. Through what mechanics does that happen? String theory? Strings made out of what? Just is pathetic. Anyway. So enough of a video. I mean, I have to make a more mechanical style video in the future, and I have to do more of them, but I just haven't had time lately. So, but you know, I did see this and I just was like, oh, this is just so depressing. This is physics now. It's just showboaty drama physics. You know, I mean, they really want to bring back mysteries. They want to bring back, it's all special and magical. They really want to do that. You can see it in their whole mannerism, and you can see it in the way they're presenting the physics. They're presenting it in this emotional, gooey way. John Bell, he came from a struggling family of horse farmers and blah blah. You know, they have to make it into something personal. Einstein was all sad because he couldn't unify. Blah, blah, blah. You know, they have to make it all into a fucking soap opera. And so you can tell, that's really not what a scientist wants. A real scientist is hungry for facts, not your sappy stories.